Hello student, I am Dr.A.K, Professor of Chemistry. Today I will continue from the last class. Chemical properties I was discussing, chemical properties of alkane. Now I am continuing chemical properties. Three properties I have discussed, that was the controlled oxidation I have discussed, substitution reaction I have discussed, that is that halogenation I have discussed, combustion reaction I have discussed, and now I am going to discuss isomerization. Normal alkanes on heating in the presence of anhydrous aluminum chloride and hydrogen chloride gas isomerize to branched chain alkanes. Okay. Normal alkanes on heating in the presence of anhydrous aluminum chloride and hydrogen chloride gas. These two are requirement. Aluminum chloride means AlCl3 and HCl gas. Normal alkane isomerize to branched chain alkanes. Major products actually in that it gives major products 2-methyl pentane. Actually it gives two products, 2-methyl pentane and 3-methyl pentane. Okay. Then these products, out of these two products, some minor products are also possible. Okay. Minor products are generally not given or not reported to organic reactions. Then here I am telling you that normal hexane, example I am telling of normal hexane, CH3 CH2 whole 4 CH3 in presence of anhydrous AlCl3 oblique HCl, both are required. It gives first product, it will give 2-methyl pentane, means 5 carbon you write and carbon number 2 methyl group you attached. Okay. Then that 2-methyl pentane it gives. And you can say other product it also gives. You know that when 2-methyl pentane is there, then 3-methyl pentane is also possible. 3-methyl pentane is also possible. Then both are isomer. Others are also possible. Minor, that is these two are the minor. 2-methyl pentane and 3-methyl pentane both are major, and minors also are there, but that is not that is not reported actually in reaction. But two major products I told you, 2-methyl pentane and 3-methyl pentane it forms. Now other reaction, aromatization reaction means it will give aromatic products. Normal alkanes having 6 or more carbon atoms on heating to 773 Kelvin at 10 to 20 atmospheric pressure. Here pressure should be high. Normal alkane it will apply for both 6-membered or more carbon atoms. If it is heated to 773 Kelvin, means 500 degrees centigrade at high pressure, 10 to 20 atmospheric pressure, in the presence of oxides of vanadium, means B2O5, or molybdenum oxide, M2O3, or chromium oxide, Cr2O3. Then in the presence of these This I am talking about normal hexane in presence of chromium oxide, vanadium pentaoxide, MO2O3 means molybdenum oxide. It gives a benzene. It gives a benzene. Okay, and actually dehydrogenation. This we have taken oxidizing agent. Then it will be this because more hydrogen is there. Normal hexane CH2, 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 you know that beginning and last CH3 is there, and between that 4 CH2 will be there. Then this hydrogen will oxidize. This vanadium pentoxide or chromium oxide or molybdenum oxide, it will oxidize hydrogen, and it forms or it gives a benzene. It gives benzene. Okay. Then this I'm telling you catalyst, vanadium B2O5 molybdenum oxide means this MO2O3 V2O5 Cr2O3. This is supported on alumina. This catalyst is supported on alumina. Alumina means Al2O3. And here dehydrogenated, and this will become dehydrogenated. Okay, and cyclized. It will give a cyclic product, cyclized to benzene, and it's homologous. This reaction is known as aromatization. Means it got the aromatic structure, ring structure. Then normal hexane converts to benzene in presence of different type of catalyst supported on alumina. Okay, toluene toluene is methylated derivative of benzene, which this toluene just like aromatization like normal hexane converts to benzene, and it can form also these things. Toluene means in benzene one CH3 group is attached, that is called toluene. That also it can form. Then now I have told about the aromatization. Aromatization in that normal hexane I told. Now this hydrogen is more. CH2 4 CH3 in the first and in the last CH3 groups are attached, and in the middle CH2 are there. But benzene only 1,1H is there. Every carbon 1,1H is there. Then what happened to this other H? Then that H converted to H2O, and or also you can understand that dehydrogenated means hydrogen gone outside, and then it converted to benzene ring, alternate single and double bond. Now next reaction is reaction with steam. Reaction with steam. Steam is more dangerous than boiling water. Steam has more energy than boiling water. This is also important question. Now then reaction with steam. Methane reacts with steam. Methane is alkane. Methane reacts with steam at 1273 Kelvin, high temperature, in the presence of nickel catalyst. And what product it will give? Then it will give carbon monoxide and dihydrogen means H2 gas. It gives two products, carbon monoxide and hydrogen gas. Okay, actually why dihydrogen word is used for the hydrogen? Because hydrogen may be atom also. But H2 dihydrogen. Dihydrogen means always hydrogen gas. Just to differentiate, correct is actually dihydrogen, dioxygen, because if you will take oxygen, the oxygen may be atom also. If you will tell hydrogen, then hydrogen may be atom also. Just to clarify, that term dihydrogen, dioxygen is used. Then okay, then here methane and steam. Steam is represents by H2O. H2O, and it forms carbon monoxide plus hydrogen, means CH4 plus H2O. Total CH4 4 hydrogen and H2O 2 hydrogen, 6 hydrogen is there, then 3H2, and only CO is will form, carbon monoxide, deadly poisonous. This reaction takes place in the presence of nickel at high temperature, 1273 Kelvin. Now next reaction I am telling you, pyrolysis. Pyrolysis means a strong heating. Okay. Higher alkanes, actually this term is used for the breaking of higher alkanes at high temperature. Higher alkanes on heating to higher temperature decomposes into lower alkanes or alkenes. When it will break, cracking will take place, long chain hydrocarbon is there, and if you will heat it, then it will decompose into a small group, a small group, or a small, you can say, this product it will give. Higher alkanes on heating to higher temperature decomposes into lower alkanes or alkenes. Sometimes double bond also will be there. Such a decomposition reaction into a smaller fragments by the application of heat is called pyrolysis or cracking. Two names are there, pyrolysis or cracking. Okay. Decomposition reaction will give many products, smaller fragments, and this process is called this process is called pyrolysis or cracking. Okay. Then example I am giving you, that suppose C6H14 is there, C6H14 hexane. Then if you will heat it strongly at 773 Kelvin, it can give three main products it will give. First, that is a possibility that it will give C6H12 plus H2. Always it should become equal. C6H14 is there, then product will be, if you will add hydrogen and carbon, then it will give, you will get same as C6H14. As for example, now one product is C6H12 plus H2, then H12 plus H2, 14, then C6H14 original. Then one product that it can give C6H12 plus H2. Other product C4H6. Then what will be the other product? The other product will be C2H6. First product was C4H8, 4 carbon, 8 hydrogen. Now then you have to bring it C6H14. So what is the remaining? The remaining is C2H6. This is the second product. Always if you will add both product, then it will give original. Third product, it gives C3H6 plus C2H4 plus CH4, 3 products. C3 means propane you are talking about, C3H6. Second product is C2H4. Third product is CH4. You add all. Then first product C3, other is C2, then C3, C2, C5, and one more CH4 is there. Then C6. Hydrogen if you will add, then H6, H4, 10, and again CH4, that 4, 14. then it gives 3 product. Then now if you will do, if you will heat it, if you will apply heat, means high temperature, then you will get these many product you will get. These many product you will get. What are the product? Then now 3, I told you, first 2 product, second 2 product, and last 3 product. 3 plus 2 plus 2, 7 product you will get. 7 products altogether. Then this is called actually, these are the fragments. This is called fragments. This you got on decomposition of higher alkanes like C6H14. Then this is called pyrolysis. Pyrolysis of alkanes is believed to be a free radical reaction. Free radical reaction, always you keep in mind that all carbon will have, whatever fragments are there, in that fragments one carbon will have 1 electron. That is called radical, like methyl radical, ethyl radical, propyl radical. Last carbon will have 1 hydrogen less, and in its place 1 electron will be there. That is called radical. Then this you should know that generally it is believed that this reaction takes place in free radical. It is a free radical reaction. Pyrolysis of alkane is believed to be a free radical reaction. Preparation of oil gas. Preparation of oil gas or petrol gas. Oil gas means petrol. Preparation of oil gas or petrol gas from kerosene. Kerosene is also, actually this will give you around 10, 12, 13 carbon. If molecule compound will have hydrocarbon having around 10, 11, 12, like that carbon, that is called this thing, kerosene. Kerosene. 3 products in the beginning, like up to 3, means CH4, C2H6, C3, H8. This type of light alkanes are petrol, and if you will go more, 5, 6, 7, then they will be come under the actually liquid form, then diesel, and after that kerosene. As the number of carbon will increase, their state will change. Gas will convert to liquid, some less number of carbon. Hydrocarbon having less number, that is the up to 3. I told you, that is the gas. Up to 4 you can tell. After that 5 onward, 7, 8, it will go up to the 10, 9, 10, that is the distance diesel. After that up to 13, it will go to the kerosene. 11, 12, 13 kerosene, and 6, 5, 6, 7, 8, 9, like that it will be diesel. And again if you will go 11 onward, then different product you will get. Then now I was talking about preparation of oil gas or petrol gas from kerosene oil or petrol involves the principle of pyrolysis. You will get petrol only by pyrolysis, okay, from the kerosene, because kerosene has more number of carbon. For example, Dr.A.K means 12. Okay, Dr.A.K, a constituent of kerosene, C12 I am talking about, kerosene oil, on heating at 973 Kelvin in the presence of platinum or palladium or nickel gives a mixture of heptane and pentane. Dr.A.K means, I told you, C12, then hydrogen, how many hydrogen will be there? Because it is alkane, then double plus 2 means 12 into 2, 24, plus 2, 26. Then this Dr.A.K, if you will heat, then it will give heptane, means 7, plus 10, 10. 7 plus 5, 12. Plus, now how many are remaining? 7 plus 5s are there, 12. Then 12 you got, and now hydrogen. Hydrogen you got? This thing 10 plus 16 plus 10, 26 equal. Then see heptane and pentane you got from the C12, H26. That comes under the kerosene. Dodecan, kerosene, carbon number 12. Okay, carbon number 12, carbon number 13. Is this carbon number 10, 11, 10, 11, 12, 13, all are coming under kerosene. And before that it will be diesel, and before that it will be petrol. Okay, 5 below 5, 5 to 10, 5 to 10, that is the diesel, and 10 to 13 it will be kerosene. Then this I have told you a chemical reaction. Now I am going to tell more about the alkane. That is very, very important, and question is asked. That is the conformation. Conformation. What is the conformation? I will tell you. Okay. Already I have once I have discussed, but now I am repeating you. Alkanes contain carbon-carbon sigma bond, that you know. Electron distribution of the sigma molecular orbital is symmetrical around the internuclear axis of the CC bond, which is not distributed due to the rotation about its axis. Here, main thing is that electron distribution of the sigma molecules orbital is symmetrical, first point, around the intermolecular axis of CC bond, carbon-carbon bond. Okay, there CH bond will be there. Then there it is a symmetrical. Electron distribution of the sigma molecular orbital is symmetrical, means same type of equally distributed around the internuclear axis of the CC bond. Around that it is distributed, which is not disturbed due to the rotation about its axis. Means around the carbon that bond that will be not disturbed, but this near the carbon, what are the electrons are there, that will rotate. Their rotation will be, that is symmetrical, but carbon-carbon bond will be not disturbed. Okay, not disturbed. Then near the carbon, suppose hydrogen is attached. Hydrogen 2, 3, suppose CH3, both carbon, suppose you are talking about ethane. Then carbon has 3 hydrogen, other carbon also has 3 hydrogen. Then this 3 hydrogen, CH, 3 bonds are there, CH, other also CH. Then this may rotate without disturbing CC bond. Without disturbing CC bond, this will rotate. Hydrogen, that electrons that can rotate. Then here, that is a conformation is related to motion. Okay, this is related to motion. Then this you can say this type of rotation, this permits free rotation about CC single bond. Okay, because electrons are symmetrical and it can move. Then this permits free rotation about CC single bond. This rotation results into different spatial arrangement of atoms in space, which can change into which can change into one another, such as partial arrangement of atoms, which can be converted into one another by rotation around CC single bonds are called conformation or conformers or rotamers. Three terms are there. Conformations or conformer or rotamer. Rotamers. Three terms are there. Question is asked. What is the conformation? What is the conformers? What is the rotamers? Alkanes can thus have infinite number of conformation by rotation around CC single bond. However, it may be remembered that rotation around a CC single bond is not completely free. Some restriction is there because CC bond is fixed. That's why it is moving, but not 100% free. Restricted movement is there. Restricted movement. Okay. It is hindered by a small energy barrier. It is hindered means restriction. It is hindered by a small energy barrier of between 1 to 20 kilojoule per mole. This is the energy barrier of around between 1 to 20 kilojoule per mole due to weak repulsive force interaction. This is why this energy restriction is there. Then due to weak repulsive interaction between the adjacent bonds. Actually, hydrogen bonds will be there. Then all hydrogen atoms have electron, then they will repel to each other also. Repulsion will be there. Okay. Or you can say near the carbon many electrons will be there. Then among the electrons, this between the electrons repulsive force will work. Okay, due to that this energy is required around 1 to 20 kilojoule per mole. And this repulsive force 1 to 20 kilojoule per mole, what I told you, such a type of repulsive interaction is called torsional strain. This question is also asked. What is the torsional strain? Then this is called torsional strain. Okay. Then now actually this conformation of alkanes you can understand very well by the diagram. I will try to send some diagram, but now just I want to brief it. Actually, how will you understand? Suppose now that ethane structure, now you can imagine ethane structure, carbon single bond, correct? And each carbon three hydrogen is attached, CH, just like a fan is there, na? Then that wings are there, like that way you can understand for here understanding. Then each carbon 3 hydrogen is just like 3 wings of a fan, both, correct? Then now just to think that if now all CH bond is moving, suppose one is stable, just for a second you understand, think that one carbon CH3 suppose it is fixed, and other carbon HCH are just like a moving. Fan will move very slowly, like that way it is moving. Then in comparison to this CC bond, they will make some angle. If some when it will be straight 90 degree, when this carbon bond, carbon means at axis, when on that axis it will be 90 degree. When it will be straight, then you can tell 90 degree. Now one wing only you consider. Now again it is that wing is going slowly, it is going ahead. And now it can make some angle 90, 95, 100, 110, 105. Correct? Then now each time some angles it is making, each time some angle is making. Again a new wing will come, new hydrogen CH bond will come, again it will move. Then when it will move by making different angles, correct? Then now this type of movement actually gives rise to this term conformation. Due to this type of movement, they are not fixed. Other carbon atom also can move. All three hydrogen CH can move, and then can make some angles in comparison to the this CC, okay, CC bond. Then this will give rise to many can say conformation. This I have told you that conformation of ethane. Ethane molecule means C2H6 contain a carbon details I am telling you, carbon single bond with each carbon atom attached to 3 hydrogen atoms, that you know. Considering the ball and stick model, ball means ball will tell about the hydrogen atom, and stick will tell about the bond stick. Just you can imagine, a stick is just like a bond, and ball just will tell about the hydrogen atom. Then you know already I have briefed you, you will understand very quickly. Considering the ball and stick model of ethane, keep one carbon atom stationary and rotate the other carbon atom around the CC axis. This rotation results into infinite number of spatial arrangements of hydrogen atoms attached to one carbon atom with respect to the hydrogen atoms attached to the other carbon atom. Other carbon atom it is fixed. Then in comparison, just you are considering, then one is fixed. Other carbon hydrogens are moving. Then with that also, in respect to that hydrogen also, other carbon hydrogens are moving. Correct? Then it can give many, you can say, infinite number of spatial arrangement. Spatial arrangement means what? In a space it is arranged. Correct? Not on the plane, not on the surface like that, upside how it is moving like that, fan is moving, correct? Not touching the surface. Like that way, it is moving. Then spatial arrangement means arrangement in a space. Arrangement in a space is called spatial arrangement. Then this I have told you spatial arrangements of hydrogen atoms attached to one carbon atom with respect to hydrogen atoms attached to the other carbon atom. These are called, special arrangement, moving also you can tell. Then these are called conformational isomers. Isomer you know. Then conformational because it is moving. Many type of isomers it is making. Isomer molecular formula is same. Structure also is same. Now it is moving. That is due to that you are getting many isomers. Then these are due to the spatial arrangement in a space. Yeah, you can say arrangement in a space. They are making so many isomer. Then this is called conformational isomers. Okay, or also called conformers. Thus there are infinite number of conformation of ethane because every time it is moving. Then you can't count how many they are moving. Many form it can make. Then one such conformation in which hydrogen atom, again now 3 main situation I am going to tell you. 3 main situation of conformer or conformation. Now listen carefully. there are infinite number of conformation of ethane, first things. Now, there are two extreme cases. One such conformation in which hydrogen atoms attached to two carbon atoms are closed together as possible is called is eclipsed conformation. Eclipsed means now this other one carbon you are considering that is a fixed hydrogen, they are fixed, just you are considering simple, that also can move, but now you consider one carbon 3 hydrogen that is a fixed. Now other carbon hydrogens are moving, then when actually both hydrogen will come, both hydrogen, first carbon hydrogen, second carbon hydrogen, if both will come just in front, just like a solar eclipse, full solar eclipse, they are covering complete, moon is covering the sun, like that you can't see from the moon side, sun you can't see, then that type of situation, but between these two it is a gap is there, just like between the sun and moon gap is there, then here that gap is bound, you just think. Then when this type of situation is there, then it is called eclipsed. Eclipse name has been given due to that eclipse only, solar eclipse. Like that way, that sense only it is given. Eclipsed conformation, when that situation will be there, closest. Then hydrogen atoms, this one situation I told you, one such conformation in which hydrogen atoms attached to two carbon atoms are as close together as possible is called eclipsed conformation. Eclipsed question is asked, and other situation, and the other in which hydrogens are as far apart as possible. Then because they are in movement, one time they came closest, after that they are going little far, then it will go maximum. Then in that situation, hydrogens are as far as possible, then in that situation is known as a staggered conformation. Eclipsed conformation and staggered. Staggered means apart, means far from each other, maximum far from each other. That is called staggered conformation. And closest, that is the eclipsed. Okay. And third situation you can see, an other intermediate conformation is called a skew conformation. Skew, S-K-E-W, skew conformation. Staggered or S-T-A-G-G-E-R-E-D, staggered, eclipsed, Then in between the two, eclipse, staggered and eclipsed, again different isomers are possible. Then that is called skew conformation. And now eclipse and the staggered conformation can be represented by two projection. Name has been given according to the scientist name, projections has been given. That is called first projection. How will you represent these two? Then two scientists, according to the name of two scientists, this projection's name is there. First, that is the Saw-Horse, S-A-W, and horse, H-O-R-A-C, Saw-Horse. One projection is Saw-Horse. Question is asked. Remember, S-A-W-H-O-R-A-C, Saw-Horse. And second, that is the Newman projection. Newman, N-E-W, new, M-A-N, man, Newman projection. Then actually both you can understand very easily by diagram. Okay, I will try to send both diagrams. Then how you can represent. Then in first case I am telling you that that is the sawhorse projection. Sawhorse projection. Then it is very easy that like that way you can see that situation I am telling you, diagram you can make little big, that distance ethane you are making. Then now you make in a three-dimensional, actually you have to make. First to understand three-dimensional structure, then quickly you will understand and you can make the diagram. Suppose now this things, one rod is there, a small rod you consider, maybe consider for understanding purpose, one half a meter rod, okay, and one end, that is the bond. This rod is representing bond. One corner, three you can say pieces you can add. All three pieces that will consider as a bond, three bond of hydrogen. A stick ball that you can consider now model, a stick ball, that three sticks will represent three bond and ball will represent hydrogen atom. Then both end you have, just you consider that this rod, both end carbon is there, and with carbon had three hydrogen is attached. Then now what you have to do, just to eclipsed situation you have to consider. Eclipse situation means H of first carbon and H of second carbons are in the front of each other, closest. Then that type of structure, when both are making distance, in the middle distance is there, just like sun and moon distance was there. Only thing is that both were covering to each other. Same situation is there, rod is in the middle, that is the bond, and hydrogens are in front of each other. Then that type of actually situation is called sawhorse projection. Sawhorse projection, understood? Front to front, they are covering to each other. In the middle, distance is there, correct? And now other projection I am telling you, that is the Newman projection. Newman projection. Then what is this projection? Then now suppose that in the middle rod is not there, correct? Suppose now middle rod is not there, then what will you think? It is there but you can't see, both are covering to each other. From the one side you will see, then what will you think? Both are covering. 100% they will not cover, maybe due to this repulsion, that is a repulsion, they will make some distance, little distance. But you consider that now, suppose in the middle rod is not there, then both will cover to each other. But fact is that in the middle some gap is there. Then if you will make that diagram, then this rod you can't see. This rod you can't see, that is the bond, CC bond. Then that type of situation is called eclipse situation in a Newman projection. In a Newman projection. Okay. Actually both I am telling you, eclipsed and a staggered position in both projection you can see. Then again I am turning to this only, what you can say, sawhorse. First sawhorse. Then one situation was that both were covering to each other, correct? Both are covering to each other. Then that situation, that projection, that projection is called this thing, sawhorse. But this is the for eclipsed, when they are covering to each other and making some distance, you can see that rod. Then that situation is eclipsed, because both are covering front to front, it is there a rod, but rod you can see, that type of situation. And other, only in that way rod you can see, but when they are making far distance, maximum distance apart, then that also that is actually staggered. Then in a sawhorse you can see the middle rod. Middle rod means middle bond carbon-carbon bond you can see. And in one case you are seeing that both are in front, all HH are in the front, and in the second you are seeing that now hydrogens are far, both hydrogens are making distance, okay, maximum distance. Then that situation is staggered. Then in a sawhorse projection you can show these two structure. Okay, these two structure you can show in under the sawhorse projection. And same things in means in both situation in Newman projection also you can show. But what is the difference? Difference is that rod you remove. Suppose there is no rod, that bond is not there, you are not able to see the bond, you are seeing from the one side, then you will see that now both are very close, both are touching, your feeling will be like that. Then that is the, when both are touching and covering to each other, that type of situation, minor change will be there, 5 degree, 10 degree difference. It will look like that, it is a covering. Then that situation is now eclipse situation under the Newman projection. And when they are making distance from each other but covering to each other, you can't see bond disappeared. You think like that, from the one side you are seeing, correct? Just like a solar eclipse or lunar eclipse you are seeing that are touching to each other, but it means not that sun and moon are touching to each other, but you are seeing like that only. Then that lunar or solar eclipse, that situation is a case of Newman projection. Both you can show like that. Two diagram you can show, but bond will be not there. Just like very good example I told you, solar eclipse or lunar eclipse. You can't see the sun because you are seeing from the one side. But if you are seeing the distance between two carbons, then that will come under that sawhorse projection. And here one thing I want to tell you, that in a sawhorse the lines are inclined at an angle 120 degree. 120 degree into 360 degree, 120 degree to each other. This is the important, okay. Sawhorse projection of eclipsed and staggered conformation of ethane, already I have told you. I will try to send this diagram, okay, both diagram I will try to send it. And in both cases Newman also same things. Newman also you will get that angle will be 120 degree to each other, okay. Then this I have told you about the these things, conformation. And now I think this relative stability I will tell you next class, because now it will take more time. Again after that I will start these things, alkenes. After finishing relative stability I will start alkenes, okay. Thank you.